Hello, we are the team XylophoneBot, a team of 5 members Aparna, Mayank, Sahana, Gagan, and Disha, working under the guidance of Preeti ma'am. Firstly, we were given a problem statement and we analyzed it from the perspective of both a customer and an engineer. And this is the problem definition we wrote. To design a xylophone playing mini robot, which measures around 24 centimeter into 14 centimeter into 10 centimeter. The weight of the robot must be 1 to 2 kg. Entire length of the xylophone must be covered. 3 tunes must be played according to the user's choice. Each tune should be played for about 2 minutes. The budget should not exceed rupees 3000. Further, we looked into the functions our bot should be able to perform and we created a function tree and divided it into 3 categories. The first one, movement of arms. The bot should be able to move up, down, and sideways. It should be able to cover the entire length of the xylophone and also it should be able to move quickly so that there is no lag while playing a tune. Second, user input. The user should be able to choose the tunes. There should be on and off mechanism available and on no commands for a while, the bot should be turned off immediately. And lastly, the tunes. Switching of tunes should be possible. There should be 3 options for the tunes and each tune should play for about 2 minutes. And finally, we were able to identify our 3 subsystems. The first one, action system, second one, manual system, and the third one, user choice. Later, each one of us generated a concept with different ways to perform each function and finalized on one concept that suited the best. This is the concept that we selected. Then we moved on to the virtual implementation of our project and designed a 3D model for our system. Here's the 3D model of our system. A rectangular base to which 2 metal servos are mounted is made up of a foam sheet. The 2 metal servos will control the movement of arms sideways. On top of the metal servo are the circular discs to which toy servos are mounted. These toy servos are directly connected to the mallets. These will control the up and down movement of the mallets. This is the rectangular base. These are the 2 toy other metal servos. This is the circular disc. The toy servos to which the mallets are connected. This is the circuit diagram of our system. This is the Arduino Mega 2560. These are the 2 toy servos that will control the up and down movement of the mallets. These are the 2 metal servos which will control the sideways movement of the mallets. A breadboard, 9-volt battery, and this is the HC05 Bluetooth module which will help us to connect to the Musics app, through which all the user inputs will be taken. Here is the flowchart of our system. On opening the Musics app, the user would be asked if to turn the bot on, and 1 will be sent as the input to turn the bot on. Then the user would be asked for an input to select among the tunes. and the input would be sent accordingly and the tune would be played for 2 minutes. There'll be a delay wherein the user can choose any other option if he wants to. If there is no further input, then the bot would be turned off. This is the bill of materials for our system. We would be requiring acrylic sheet and foam sheet of different dimensions for the base, circular disc and the platform. Nuts and bolts as well as screws would be required to connect all of these. Jumper wires, Arduino Mega 2560 and the Bluetooth sensor HC05 to connect to the Music's app. Metal servo for the sideway movements, toy servo for the up and down movement, L clamps, nylon ties which will connect the toy servo and the mallets, breadboard, 9-volt battery, two-way relay module, and the xylophone mallets. Motor sizing and battery sizing of the system. As we would be requiring 2 metal servos and 2 toy servos. Now we know that torque is equal to force into radius. Also, torque is equal to mgd by 2 into factor of safety, where m is the mass of the foam board, g is the gravitational acceleration, and d is the diameter. Here, mass of the foam board is equal to 5.0272 gram. Gravitational acceleration is equal to 9.8 meter per second square, and diameter is equal to 0.16 meter. Thus, the torque would be equal to 0.00591 Newton meter. Battery sizing. Current consumed is equal to current drawn by each servo into number of servos. Now, here current drawn by metal servo would be equal to 1000 milliamperes into 2 as we require 2 metal servos, and current drawn by toy servos is equal to 300 milliamperes into 2 as we require 2 toy servos. Thus, the total current drawn is equal to 2600 milliamperes. The functional specification of our system. First subsystem manual system, which will be controlling the on and offing of our system and handling the data regarding which tone bar to be hit. Secondly, the user choice, which would send information about which tune has to be played. This would be done from the Music's app. Also, information about switching of tunes and the duration uh, of which the tune should be played. And finally, the action system, which handles the movement of mallets up, down, right and left, each of which would be done by by an angle of 10 degrees and covering the entire length of the xylophone. Modeling and simulation. This is our Arduino Mega 2560. These are the breadboards, the toy servos that will be controlling the up and down movement of the mallets, and the metal servos which would be controlling the sideway movement of our mallets. Here, these are the plates of the xylophone. Now, whenever a tune has to be played, and according to the tune, these plates have to be hit, the metal servo would move the mallets to the particular plate, whereas the toy servos would help in hitting the mallets on the plate. Thank you.